So here's a graph of f of x, and it says assume f is twice differentiable. We can find the first derivative and the second derivative. So they said at x equals -1, the graph of f is increasing or decreasing. All right, let's see. Where's my -1? Right there. I think the graph is definitely going down from left to right, isn't it, at that point? So because the graph is going down from left to right, we will say the graph is decreasing. Too easy. What's going on? All right, what's next? At -1, the graph of f is concave up or down. Well, we can figure this out by sketching a tangent line. So let me sketch a tangent line at this point. If you were to sketch a tangent line, it would be like this, right? It's kind of hard to see, but it will be definitely below the graph. Okay, let me try to do a little better. The purple pen. If I sketch a tangent line, the graph will sit above the tangent line, right? So I'll say the graph is above the tangent line. The graph, I'll say f is above the purple tangent line at x equals 1. So this graph is definitely concave up. Remember in the other examples, we were talking about how if the graph looks like this is concave up. And if the graph looked like this was concave down, right? The thing about this graph is so wide, it's hard to see any kind of curving going on. But if I try to force this, okay, if I try to sketch a curve, you see how this graph is curled up to the left, right? It's kind of curling up to the left. So this is definitely a concave up graph because concave down graph will be pointing down. So we will say the answer down here is concave up. All right, now they're asking which one of these is the smallest. Okay, first they're asking us f of -1. Well, this is asking for the function value. Well, at -1, where is this function at? Well, I can see at -1 is up at 3, right? So the function value f of -1 is 3. We know what that is. So I'm going to make a note of that f of -1 is 3. Now let's see. They're asking us for f prime of -1. So, all right, the derivative at x equals -1. Now we can find the actual value by reading the slope of this purple tangent line, but may not be that accurate. But here's the thing though. Notice how the purple line is going down from left to right. So what will be a slope of a line that is going down from left to right? A negative number, right? So, we don't really have to, I don't think we have to find that exact value, but this is going to be f of -1 is going to be a negative number. It's a negative number. F of -1 is negative. And here's my reason, okay? Because f is decreasing. At x equals -1. See, that's what we kind of talked about in part A, right? Because this is going down from left to right, at that point, the slope of the tangent line is going to be negative because this is decreasing, right? Now, let's talk about this concavity, like f prime of -1. Again, like we won't be able to find the actual second derivative to plug in -1, but what do we know about the concavity? That this is concave up, right? This graph is concave up. The second derivative must be positive. And what's the reason? How do I know that? Because f, the graph of f, is concave up at x equals -1. And that's the second clue that we had to answer, or the third, second clue that we had to answer. Now let's see, which one of these is the smallest? 3, some negative number, some positive number. What's the smallest number out of a 3, negative number, and a positive number? Well, negative numbers gotta be the smallest, right? So the answer is going to be f of -1, because f of -1 is the only negative number. 3 is positive, and some unknown positive number is also positive, and everyone knows that negative number is always smaller than a positive number. So the smallest number is going to be f of -1. So that's it for page 134. And in this example, we were given the graph and we answered some interesting questions that had to do with the first derivative and the second derivative.